Sorry about that. We got interrupted. We're going to press enter so that plot 1 is highlighted. Notice it's darker. And then what we'll do is on the instructions here, it says go to zoom and then zoom stat. So zoom, and then number 9 is zoom stat. You can arrow down or you can just press number 9. And what that does is it fits the window to our data. So my question to you is, what does this data look like? What do you think we have for this data? Well, it looks to me like it's linear. So once we've decided what kind of modeling we want to do, we're going to press stat again. And then we're going to go to calculate. And we want to pick the type of regression that we want. So this is linear regression, number 4. Number 5 is quadratic regression. We have cubic, quartic, and even if we go down, that ln is a natural log. There's an exponential, a power, logistics, sine. There's a lot of options. But we're going to go with this very first lin reg, because that's linear regression. So we're going to be using lin reg. And it asks us these questions. Do we have our x values in L1? Yes. Do we have our y values in L2? Yes. And you can even go down and store the equation, which we're going to do. So where it says store regular equation, I want to pick y1. So if you have an older version, you would press vars and go over to the y variables, and under function you're going to select y1. If you have one of the newer versions, whoops, I'm going to have to go back through. If you have one of the newer versions of the calculator, you can press alpha F4, and it's a quick way to get to the y variables. And then we're going to press calculate. And it gives me y equals ax plus b, and it gives me what to plug in for a and what to plug in for b. And now that we have the equation saved, it actually saved it in y1. So when I hit graph, we're going to see how close that line fits the data. And it looks good. Next one. The following table gives the amount of federal tax paid per capita per person for selected years from 1995 and projected to 2018. So it says we want to create a scatter plot of this data with X representing the number of years after 1990. Okay, so key here, years after 1990. So this would be a 5, 10, 15, 20. Ooh, what would this be? 23, 25, and 28. And our y, so this is our x, and this would be our y. Okay. So we're going to go again to stat. And a quick way to clear the list is to press 4, enter, and it's going to, never mind. That's not the best way. Sorry. Edit. The easiest way is to go up to L2, press clear, enter. Go up to L1, press clear, enter. That other way has too many commands. If you press the delete button, you're going to delete the label and everything, and you don't want to really delete it, you just want to clear it. Okay, so 5, 10, 15, 20, 23, 25, 28. 5110, 7177, 7228. All right, so to get to the scatter plot, I'm going to press Y equals. I want to clear out anything in Y equals. I want to make sure plot 1 is on. Then I'm going to press zoom and then zoom stat. It's going to change the window to fit the data we have. And what does this data look like? Well, it's not a straight line. It's more of a wave. And so I'm thinking cubic, and it even tells me that here, so this looks like it's cubic because of the turns. So I'm going to go back to stat, go over to calculate, and we're going to choose cubic regression. And again, I'm going to store this in Y1 and press calculate. This time it's giving me something x cubed plus something x squared plus something x plus something, and it gives us all the numbers to put in. So we want to write that down, and 3 decimal places is good enough. And then minus 93.013, and then plus 1373.877 x. Then D is the constant, 393.784. The beauty of doing it this way on the calculator is that I don't have to retype that equation in. It automatically saved it into Y equals, and it goes even further in the decimal places than we could. I'm going to press graph and see how good it fits. Now, I missed a couple of them, but it's a pretty good fit. Now, how could we use this to predict the per capita tax for 2020? So 2020 would be when x equals 30. Now, feel free, if you would like to just plug in 30 in for all the x's, you could. But the beauty of the calculator is, since we have the function in our Y1, I can hit trace and type in any x value I want. Now, right now when I hit trace, I'm on the plot. Do you see how it says plot 1? I'm going to right arrow over, actually I'm going to go down, and now I'm on the line Y1. So you want to see Y1 up there, and you can press 30 and it will jump up to the estimate. 498, basically 2. Tax per capita. All right, there's another way we could plug in that 30. If we go to the home screen and we do that alpha F4, we pull up Y1 parentheses 30, and that's going to plug in 30 into Y1. That's another way to do it. And I rounded up to the whole because it was so many decimal places. All right, next example. Mainly because of better nutrition and healthcare, the number of years that Americans are expected to live has increased and is expected to continue to increase. So we have here, the table shows the expected lifespan based on the year of birth from 1920 to 2050. So we're going to create linear and quadratic models that give lifespan as a function of birth year, with X representing the number of years after 1900. And we're going to decide which model is a better fit. So first we need to put the data in. And since it's after 1900, this is going to be a little bit easier. So 20, 30, 40, 50, 60, 70, 80, and so forth. So we're going to go into our stat, edit, up arrow, press clear, and it clears that whole list. Clear. Remember, you don't want to delete the list, just clear it. And so 20, 30, 40, 50, 60. Y'all are probably faster typers than me. So in 1920, people only lived to be 54. Well, people born in 1920, which would kind of make sense because if they were born in 1920, they would be in the 20s in 1940, and we were at war. Whoops, whoa, not 800. That would not be good. You want to make sure you don't make those typos like that. I almost put 844. That would mess up my data. So I'm going to go ahead and look at the data. We already had our y equals. And I'm going to go zoom stat. And I can see where either linear or quadratic might work. So let's get a linear model and a quadratic model. So I'm going to call the linear y1 and the quadratic y2. So to find the equations, you press stat, go to calculate. Linear is number 4. And I'm going to store that in y1. And I get 0.213x plus 54.722 basically. Now I'm going to run the quadratic regression. And this one I'm going to store in y2. So I'll have them both on my graph. When I hit graph, now my calculators are color version, so Y1 is going to show up first, and it's in blue, and the red is the quadratic. So which one, just by looking at it, looks like a better fit? Well, I think the quadratic looks pretty good. Use each model to estimate the lifespan of a person born in the year 2000. So, 2000 from 1900 was that 100 years later. Okay, so I'm going to do Y1 of 100, 70, basically 76, and I'm going to do Y2 of 100, and I get basically, that would round up to, well, let's go ahead and do decimal, 77.7. Let's try 2050. So these are pretty close. So 2050 would be 150 plugged into each. So which one seems to fit the trend better? Do you think it's going to jump, instead of being at 84, going to jump to 86, or would 83.5 be a better estimate? It looks like the quadratic seems to be a little bit better. Even though it went down a little bit, it's closer to the projected amounts we have there. All right, number 5. The following table shows the time it takes a Corvette to reach speeds from 0 to 100 miles per hour in increments of 10 miles per hour after 30. Create a scatter plot of the data. And notice, since we don't have those years, those can just go in as our X values and our Y values. Whoops. Let me clear out our other equations, and then hit zoom 9, and it's going to refit the data. And this time they're asking us to use a power function. Okay, so we're going to try using a power function. That's a little bit lower, and it's PWR for power. And we want to save it in Y1. Okay, so a power function is just something times x to the something power. So this would be y equals 21.875 x to the 0.666. Ooh. And let's look at how that, see how well that fits. So we're going to hit the graph button. That fits pretty good. What does the model indicate the speed is 5 seconds after the car starts to move? So I want to plug in 5. So I can either hit trace and then arrow down to get to the curve, and then press 5. It says it would be 63.9 miles per hour. Use the model to determine the number of seconds until the Corvette reaches 110. So I'm on the line. I'm going to go along the line till I reach around 110. Not letting me go any further. So if it's past, it's at 11 seconds, we're at 108. So it's going to have to be after 11 seconds. Let's try, we're still in trace, 11.5. Is that far enough? It's not letting us. Let's go to the main screen. We can do it there. Of 11.5. Well, that's a little bit past it. And you can up arrow and just edit this. How about 11.4? That's good. Let's try 11.3. Ooh, that's good. 11.2. 11.2, we're not there yet. So 11.3 seconds.